Hello everyone. This week's unfinished project is about a suspension. I'm going to perform a nonlinear static analysis to find out how much load is required to compress the spring until some limit. And we will be able to see, of course, the pressure distribution as it's shown in this video. When I copied the unfinished project, I noticed that the CAD model is the old format and SimScale has a new CAD upload option. Therefore, we cannot use the old one, but it's easy to overcome this. You just need to download the CAD model and re-upload it by drag and drop. And it asks you to choose the format. I checked this zip file and it is step format. So that's it. Now the CAD model is, as you see, recognized properly. I will create a simulation, a static analysis, create a simulation. Contacts are automatically identified, but they are wrong. But before that, I want to switch to nonlinear static analysis, because in nonlinear analysis, I can discretize the arbitrary time into multiple time steps, which will allow me to see step by step how the spring is compressed. Now, coming to contacts, it just identified two contacts, but they're wrong. So the first contact is between these two cylinders. Here it says bonded, which means glued, but I want this cylinders to be able to work in reality sliding on each other, inside from each other. So sliding contact. Then the second one, bonded contact, which is fine, but I need another bonded contact here. So let's create a bonded contact. I will hide the spring now and select my master contact. Then invert the visibility and this time select the slave contact. And that's fine. Now you can of course use the physical contact, but here I don't think that it's needed. But if you want to increase the complexity of your simulation, you can switch to physical contact. Now, material. I guess steel material is used in such elements. Of course, before starting a simulation, you need to know exactly what you are simulating. You need to know the exact materials and material properties. Here, I will use just simply linear elastic model, but yeah, you need to know your material properties and perhaps switch to elastoplastic model. Boundary conditions. I want one fixed support at this end perhaps, and I want to create some displacement, fixed value. So here I want to dictate the solver with until the end of the simulation compress this spring by 4 centimeters. That's how I do this graph icon, and define the time. Arbitrary time will be between 0 to 1. On X direction, I do not expect any displacement. However, in Z direction, I want towards the negative Z direction 4 centimeters displacement. All right. Finally, I want to add some result control items to be able to measure the reaction force during the compression. So where did I apply my fixed support? It is here. In the fixed support, I should expect the reaction. So let's create sum of forces, but reaction forces, exactly where I applied the fixed support. Let's name it reaction. Then I will do the same. It does not necessary now, but I will still do it. I want to measure the force where I applied the displacement, but this time I need to measure the nodal forces. That's fine. I will reduce my mesh size because yeah, I want to keep the simulation time small as possible. Here, I will receive an error because in this simulation, I only applied a displacement. I did not apply any load. This will cause numerical issues. Therefore, I need to change, as the error message warned me, from convergence criteria from relative to absolute. This will overcome the error. I will even reduce the tolerance smaller because I want this simulation to be quick as possible. Of course, don't reduce it for the accuracy. Keep it. Actually, I increased the tolerance. Don't increase it for the sake of accuracy. Here, this is only for demonstration purpose. Let's run the simulation. It will first generate the mesh, and seems like in 15 minutes the simulation will complete. See you in the next video.